Now guys, in this video, I'm going to show you another way to look at inverse functions, okay? I showed you the algebraic, simple, straightforward way to look at it. Now I'm going to show you actually the approach from geometry, okay? And remember, these mathematics topics are actually not independent. One topic links to another. One still appears in another, and one of those is actually algebra. And that's why I encourage really all of my students to say, guys, make sure you get your algebra right, because it's gonna appear there, whether it's financial maths, calculus, geometry, trig, it will always be there. So let's have a look at this. I've plotted here the line actually y equals to x, okay? A line of reflection. It is G, here it is G, y equals to x. Now I'm gonna show you one amazing thing that happens when I reflect this parabola about this line, not parabola, hyperbola, about this line y equals to x. Now, what is this? What is the equation of the parabola? Here it is in purple. If you will look with me here where my cursor is, this here, I'm also using purple somehow, ironic. That's where my equation is. You can see y equals to 1 all over x minus 2, and then minus 1, of course. Now, let us take this and reflect it about the line y equals to x. Now, I've got a cool tool here on GeoGebra. I'm just going to come here and say reflect about line. And what it tells me here, it says select object to reflect, then line of reflection. So which object do I want to reflect, guys? I want to reflect the hyperbola. What is the line of reflection? I select that line, and guess what? There is my reflected graph. Maybe I can change this color and use a different one so that you guys can have a clear look. And there it is. I've picked up orange here, and you can see now that there is a difference. So this is the reflected version. The orange is the reflected version. Now, what I've done is, before, of course, I started recording, I actually figured out the inverse of this equation here, of this hyperbola. But maybe for your interest and curiosity, let us go ahead and use the algebra to figure out the inverse and see if that inverse that we find algebraically can correspond with the geometry here. Okay, so let's see. The original function is y equals to 1 over x minus 2 minus 1. Inverse, according to that rule, we have to switch between y and x. Okay, then I'm going to have x plus 1 here, and I'm going to have 1 over y minus 2. Then I just change these two things here. So y minus 2 is 1 over x plus 1. And so y is actually 1 over x plus 1 plus 2. There's my inverse. Okay, somehow I have also put up the equation for this inverse. Here's the equation, and then here's the equation. Now I'm going to remove this orange graph. Now let's picture how the orange graph is. It is passing through y equals to 3 here. The y-intercept is 3. I hope you can see that. Now let's see if I plot the inverse, will it do the same thing? Okay, the inverse should appear in green. Bravo, there it is. We can see the correspondence between the geometry and the algebra. And trust me, believe you me, guys, it's going to work for literally any function. Whether it's the exponential function, whether it's the quadratic function, which we did in the first video, it will always work. Now, here's one cool thing that I actually wanted to show you about the hyperbola. Check. If I want to find the inverse of the hyperbola, even if I don't have this the luxury of this tool called GeoGebra, this lovely tool that Mr. G is using here, this is one thing that you should notice, and this is one thing that you can always do. The original equation was y equals to 1 over x minus 2 minus 1. Now, I can just figure out the asymptotes here. Okay, The asymptotes here, I have x is equal to 2, y equals to -1, right? That's what I have. Now, this is for the original function. Now, remember what we did in the previous video when we were talking about the parabola? When we do the domain and range, the letters had to change, okay? Remember that? And that's the trick that I'm going to use. So for the inverse, the asymptotes, I must somehow have the following. I must have y equals to 2, and I must have x equals to -1. Of course, this gives me x plus 1 equals to 0. And so, because I've seen that the form of the equation does not really change, I know that the inverse should be actually, let me use the inverse notation for your sanity. I'll use this and say, I now know actually this has to be 1 over x plus 1. All right. What is my y there? My y is 2. Without any difficult algebra, this is what I figured out. This is what I can simply do. And that's the beauty of doing some geometry, guys, and relating it to everything that you are learning. So don't look at the mathematics topics independently. Know that one can link to another. As a matter of fact, if you are not aware, the number patterns that you are doing are actually functions. This line here, y equals to x, is a number pattern actually. This function, y equals to mx plus c, it's a number pattern. Are you with me, guys? The function y equals to x squared, it's interesting. We call this the linear or we call it the linear function. And guess what? Linear just means arithmetic, and you have the arithmetic pattern. We call it the quadratic function, y equals to x squared. And guess what? You do get a quadratic sequence. You see that? You see what I mean? So you have a geometric, let me just nail it. You have the geometric sequence. Guess what? Geometric sequence can be represented by the exponential function. So that is one thing that I am trying to drive home here. Don't look at these topics independently. Always try and think, how does this link with some of the algebra I did? How does this thing link with some other topic that I linked? Exponents, for example, even in finance, they are there. They are being used really so much so. That's why in some question papers, they ask you finance questions, but they require you to use what? Your knowledge of exponential functions. Okay, guys, I'm gonna stop it here. In the next video, we will start now looking at questions, how to tackle them, how to answer them using what we discussed. Cheers.